Okay, so let's do something like 13/7 minus 2/3. So we want to subtract two fractions, right? So we have to have a common denominator to do this, or we can use the shortcut, right? So what do y'all think? Do y'all like the shortcut? Do you want to go with that, or do you want to get common denominator? It's totally up to you. Short, you want to do the short? Let's see how the short would work. If we did the shortcut using that formula, what we're going to do is multiply these two together, right? Multiply those two. What's 13 times 3? Remember I said, have your calculator handy. If you're not okay with that arithmetic, what is that? 39. Okay, and then here's the important step, minus, right? Because we have subtraction. So put a minus here instead of a plus. Now these two multiply, 14. And then you divide the entire thing by 21. Now you take 39, take away 14. What's that? What is it? 25. And then over 21. Now, the only thing we really have to concern ourselves with when we use the shortcut is this fully reduced? Is there a number that goes into both of these or not, other than 1? So what do you think? I think so, right? 2 doesn't go into both those, 3 doesn't, 4 doesn't, 5 doesn't. So we are fully reduced. Box it up. You know, there's a way you can check to see whether or not it's fully reduced if you find what's called the prime factorization of the numbers. So like you could rewrite 25, you could rewrite that as 5 times 5, right? And neither one of those numbers can be broken down further. And on the bottom, you can rewrite 21 as 3 times 7, and you can't break down the 3 or the 7 any further, right? And as long as nothing cancels, you're good. Right? Let me give you a different example. What if we would have had 24 over 21 instead? And if you're having trouble figuring out a number that goes into both, try and break them down. So 24 can be rewritten how? Just anything you can think of. 8 and 3. Okay. Can the 8 be broken down further? As what? 4 and 2. So you could look at the top as 4 times 2 times 3. Can you break, oh, and the 3 can't be broken down, right? Can the 4 be broken down further? 2 times 2? 2 times 2 times 2 times 3. I know this seems tedious, but we have a name for this. It's called the prime factorization of a number. You can always break it down into just prime numbers. And then on the bottom, what? 3 and 7, right? That's it. That's all you can do. 3 and 7. 3 and 7. Does anything cancel? The 3s, right? That's it. That's all that cancels. So you've got 2 times 2 times 2. That's 8 on top and on the bottom 7. So that's the furthest it can be broken down. This is just in case you're having trouble like coming up with numbers. Like maybe you look at that and you're like, yeah, 3 goes into both. I'm done. But if you have any issues, you can do this. We good? Okay. So we're going to move on now. Okay, we're going to move on. In theory, we know how to multiply, divide, add, and subtract fractions. This should all be some sort of review for you, obviously, right? You've done this at some point in your life in the past. So now what I want us to be able to do is deal with a different type of number. So when you have a fraction, right? When it comes to fractions, there's 2 types of fractions. What we call proper fractions and improper. All right, a proper fraction looks like this. 3 over 8. An improper fraction looks like this. 8 over 3. And the thing that you can think of to distinguish between the two is that with the proper fraction, the number on top is smaller than the number on the bottom. And with improper, it's the other way around. The number on top is bigger than the number on the bottom. You see the difference? When you have an improper fraction, there is a way that you can convert this into a new notation that I'm sure you saw at some point in your life, something called a mixed number. Does that ring a bell? A mixed number. So let me write down what the mixed number is for this, and then I'll show you how you would do it. It's 2, let me just think for a second, 2 2/3. That's the mixed number form of this fraction. So given fractions, there's two types, proper and improper. If you ever have improper, you can always convert it to a mixed number. Do y'all know how to get from here to here? How? How do you go from here to here? How do you go from 8/3 to 2 2/3? Yeah, so you're dividing it. That's all you're doing, right? So this is to get from here to here. Okay, how do you do this? How? You do this. You take the 8, put it in the division box, you put a 3 on the outside. Old school division, right? And now you just ask yourself, how many times does 3 go into 8 without going over? Twice, right? So 2 times 3 is 6. What do you do now? Subtract. 8 take away 6 is what? 2. Then you say, how many times does 3 go into 2? It doesn't, right? So this is your remainder. Remember, so this, we're going way back. You go like remainder 2, remember that? And then that answer gets converted to this. You say, okay, this 2 right here is this 2. Then you put your remainder on top, and then you put the divisor on the bottom. Let's do another one. What's 15/4? Convert that to a mixed number. Right, this is improper. 15 is bigger than 4. Try it on your own. See if you can convert that real quick to a mixed number. Do this thing. Let's see what you get. I like to call on people. It's fun. Let me get my pen out. I'll take a volunteer first. Who wants to volunteer? What's your name, sir? Matthew? Rios, yes? You were here last time. Yes. Very good. Okay, what do you got? 3 3/4. I like the way you said that. 3 3/4. So 3/4. Show of hand, yes? We're all good with that. Okay, good. No questions? All right. How about the other way around? What if I give you a mixed number? Can you turn it into an improper fraction? Yes, I see people saying yes. So let's see, how do we do it? So we do, as an example, let's convert this to improper. Okay. So let's do 3 1/5. So who wants to volunteer this to explain how we do this? Go ahead, what's your name? I would say that I'm going to memorize your names, but I'm really bad with this. Oh, there you are. Okay. Go ahead, Reese. So this 3 multiplied times the 5, okay? And then add 1. You all remember that format? You do this number times this. So you're going to do 3 times 5. And then you're going to add whatever number's here. 1. And that gives you 16, right? So what do you do with that number 16? Divide it by whatever this number was, 5. That's just kind of like a little pattern thing you have to memorize. Does it look familiar at all or no? And I see a lot of you saying yes, and then some of you are like, what the hell did you just do? All right, let's do another one, okay? we're doing whatever this number is, multiply it times that, and then add that number. And that becomes the top. And then the denominator will always be whatever number's here. Okay, so how about this? 2 and 4/5. 2 4/5. What's your name? Haley. So you were kind of looking at that and confused a little bit. Okay, so let's do this one together. So what do you think we would do?
Multiply 2 and 5.
Okay, so what's 2 times 5?
10.
10, and then we're going to add to that what?
4.
4. So what's that?
14.
14. So I'm going to say this is 14, and then you'll divide it by 5. You're done. Okay. Okay. Anyone? Do I need to do more of these? Y'all are okay? So here's what we have. We know how to add and subtract fractions, right? Multiply and divide fractions. We know that fractions can come in 2 forms, proper and improper. If we're given a mixed number, right? These are called mixed numbers. That's a mixed number. That's a mixed number. If we're given a mixed number, we can always convert it to a fraction. Or if we're given a fraction improper, we can go to a mixed number. So now a question, right? It's time to do a problem. For Halloween, let's do Christmas, I guess. For Christmas, I bought 2.5 pounds, LBS pounds of candy. And 3 1/3 pounds of, what do you eat at? What do you eat for Christmas? Candy. You don't even eat candy for Christmas. What else do you candy? So those are my candy canes. Then 3 1/3 pounds of what? Popcorn. That's a lot of popcorn. Okay, popcorn. All right. How much more popcorn is there? You know, compared to the candy, how much more popcorn do I have than I have candy? You understand the question? All right, so there's the problem with word problems, you have to interpret them and you have to convert them into math. All right. So I'm going to go volunteers until people stop volunteering. Okay. So, and it's got to be a new volunteer. So I need a volunteer to somehow turn this word problem into a mathematical statement for me. So go ahead. Who are you? Your name? Sorry.
Nathan.
Nathan? Okay. Popcorn from the candy. So can you just tell me what to write?
So I'd say
3 1/3. Okay. Okay, that is correct. The way you said it wasn't. So this is important because we want to make sure we understand the language. I think you said, and you correct me if I'm wrong, I think you said you subtract the popcorn from the candy. You're actually taking the candy and subtracting it from the popcorn. If you say popcorn from candy, it would be written the other way around. Wait, how did you say it again? Hold on. You said
so.
Okay, so if you
The candy.
okay, yeah, okay, there you go. So if you say popcorn from candy, then it would have to be written this way, which would be not what we're looking for. With subtraction, the order does matter, right? When you add two things, the order doesn't matter, but subtraction, it does. We clear on this? You don't know what to do now? No? Yes? What are you going to do? turn them into improper fractions first. So we're going to use the method that we just learned or just recalled or remember that you're going to turn this into a fraction, turn this into a fraction. Once you've done that, you're going to go do that, right? Now, I know some of you are going to say, can I just do 3 minus 2 and get 1? And then do 1/3 minus the half. And I would say, if you're super good at this, go for it. But it's this danger zone right here. I intentionally made this problem dangerous. My recommendation is to always go to improper fractions. In fact, I wish we never taught mixed numbers. I wish we just removed it from math education completely because it just messes people up. All right, you ready? What's this turn into as an improper fraction? Volunteer? Go ahead. Martin? There you are. What is that? 10/3. 5/2. All right, next volunteer. Raise your hand if you want to do. Go ahead. What did?
Trinity.
Trinity. Okay. What now?
Then you multiply the 10 by 2 is 20.
So you're going to do the shortcut, right? So you go this and this. That gives you 20, and then what? Minus 15. So now you're doing this times this, and you're using subtraction, and then over. Careful. 6. Yes, good. So you're going to multiply those two. All right, good. May as well finish it up. 5/6. That's it. Leave it like that. On your exams, quizzes, when you get to an answer, unless I say, hey, write that as a mixed number, or hey, convert that to an improper fraction, unless I say, you can leave it however you want. Right, this is correct. 5/6. Questions? Let's do another one. How about I give you one? You try and work it out on your own. Okay, yeah, it is. Right. A recipe calls for 2 1/5 pounds. Gosh, I'm messing up my pounds of butter. All right. The idea of recipe calls for 2 1/5 pounds of butter. All right. You wish to triple the recipe. How much butter is that? Too much, right? You need. All right, so I want you to work on your own. You can talk to each other if you want to check your work, but set up the math that you need to do for that. It's going to be some sort of thing here like this, and then execute the math. And then when you have an answer, raise your hand, and then I'm just going to kind of start talking once enough people have their hands raised. I don't care how you do it how you are comfortable doing it. My recommendation, always convert mixed numbers to improper fractions, always. That's my recommendation. How's it going? Did you go last time or not? No? Okay. Are we full in here? You mind taking that one right there? Yeah, just so people have space to work out better. What was your name? Andrew Jones. Okay, thank you. All right. So you're going to raise your hand to let me know that you have an answer. Okay, you drop your hand. I just want to kind of get a feel for how long. Okay. Can I answer your question? Yeah, I always recommend you go to improper. It's just, I think, easier to work with, everyone's got their own sort of. I'm gonna call on someone randomly now. I don't care how you leave it. Yeah, I don't care how you leave it. If you want to leave it as improper, leave it as improper. If you want to go into a mixed number, go to a mixed number. Do you all need more time? All right, let me call on someone. Gavin. No, I'm just kidding. That would be kind of rude. All right, let's see. I'm gonna just go off of, how about Elizabeth?
The improper.
So tell me what you did.
Oh, okay. So I converted the 2 1/5 to a improper fraction.
Okay, and then what did you do with it once you did that?
I multiplied it by 3.
Okay, that's what I want to start with. Everyone needs to understand that the mathematical operation here is to multiply by 3, because we're tripling the recipe. That's the key word, right? We're tripling that recipe. So you're going to multiply the 2 1/5 times 3. Before you did that, though, you converted the 2 1/5 to
11 over 5.
so 11 over 5, and then you multiplied by 3.
I put it over 1.
Good. So to multiply 11 over 5 times 3, you have to rewrite the 3 as a fraction. So 11 over 5 times 3 over 1. And now?
I did the shortcut way and put 11. 11 times 1 is 11.
Careful. You're multiplying. I think you're doing adding. Right?
Oh my
So-
God.
So when you have multiply, it's the easy one, right? You just go straight across.
Okay, so
Yeah.
then 11 times 3 is 33, and 5 times 1 is 5. so
Perfect.
it's 33.
There you go, 33 over 5. Good. So just be careful with those sorts of things, right? I mean, so are we all, we're okay to see how Elizabeth responded? Made a little hiccup there. It's all good. We're not going to be like laughing. Right? So I want everyone to feel comfortable here. No one cares if you make a mistake in here. It's okay. That's why we're here, right? You see someone else make a mistake, maybe that'll help you not make that mistake. And I'm sure Elizabeth won't make that mistake. Yeah, right? Okay. That's it. We're getting out of fractions. I think this has been enough review of fractions. Hopefully the homework, I'm gonna give you a pretty good assignment for homework for you to practice. And there will be some word problems. In fact, it's mostly going to be word problems. So we'll see how it goes. All right, next thing I want to talk about. Well, I'm not even going to tell you yet. I'm actually going to put a problem on the board. I'm going to see what you do. All right. So what I'd like for you to do is this. I'd like to see if you can figure out what 12 divided by 3 times 2 is. This has nothing to do with fractions. This is just what's 12 divided by 3 times 2. Is that sufficient time? We're good? Okay. Would someone like to volunteer their answer? 8? Okay. Anybody have anything different that wants to volunteer? 2. Anybody else have something different? Let's show of hands. How many 8s do we have? 8. Let's see. Come on, let me see your hand. 1, 2, 3, 4, 5, 6, 7. There's 7 8s here. And then 2s. Oh, wow. 1, 2, 3. 15. So that's about 2/3 of the class got this one, and about 1/3 of the class got that. Rough. Okay. 60% or so of you got this. The other 30 or 40% got this. So a lot of you are wrong, right? In either case, right? So let's talk about the 8. Who got 8 that wants to tell me how they got 8? Go ahead.
Okay, so use Pemdas, right?
Pemdas.
Yeah, so parentheses, with no parentheses.
Okay, hold on, Pemdas. Let me write that down because make sure everyone knows what you're talking about. Pemdas. Can I write it this way?
Yes.
I think this is something a lot of you have seen. It's a way of remembering the order in which we do things, right? This stands for parentheses, exponents, multiplication, division, addition, subtraction. Y'all seen that before? Yes? Okay, continue. So you said
So
there's no parentheses, so you didn't do parentheses.
yeah, there's no exponent.
Didn't do exponents.
And then this is the M, so you put it next to the order from left to right. Division comes before the multiplication. You divide first. If you're like, function the same, and one's on the left, multiply, or
That sounds complicated, but I understand what you're saying. So time out. Who got 2? Okay, can you explain to me with Pemdas what you did? So you did no parentheses, no exponents. Multiplication's next, right? So you do this multiplication, 3 times 2 is 6. So now you're here. And now 12 divided by 6 is 2, right? What's your name? Diego's making up some shit, right? Doing that, right? Diego is correct. All of you, everyone else is wrong, okay? So Diego's right. Learned it the right way. These people are right, okay? It's confusing. I understand that. That's why we're talking about this. This is taught, and it's taught. It's either taught correct and you don't remember, or it was taught wrong because the person who taught you learned it wrong. All right. Multiplication and division are equal in this. Okay. It's not multiplication before division. It's whichever comes first as you read it from left to right. That's what Diego said, right? So when I'm looking at this problem, this is wrong. Right? It's okay. That's why we're here. That's why we're doing this. So when I look at this problem, I say there's no parentheses. Okay, skip parentheses. There's no exponents. Nothing's raised to a power. Okay, good. Now, multiplication and division. Do I see any multiplication and division? Yes. Which do I do first? I do whichever comes first as I move from left to right. So I'm going to read this like a book, and I'm going to go this first. Okay. And 12 divided by 3 is 4. And then times 2. And 4 times 2 is 8. If you have a calculator with you, I want you to type in 12 divided by 3 times 2. Just type it just like that into your calculator and hit enter and see what you get. Okay. The calculator knows the order of operations done properly, right? Now, when it comes to addition and subtraction, it's the same thing. It's not this before this, it's grouped together from left to right. Guess what it was when I learned that correctly for the first time? I was in college. Now, I'm pretty sure my teacher told me the right way, I just wasn't paying attention. But I remember being pissed. I was like, man, I thought it was someone else's fault. Who cares? That's the right way to do it, okay? So now you know, right? Now you know. Why do we do it? Why do we have to have an order of operations? Why do we need an order of operations for now? Because if you don't have order, people are going to get 2 different answers, right? So, I'm building a bridge and I do it my way and I get one answer. You do it your way, you get a different answer. We need to be consistent, right? So the order of operations is established so that we have consistency in our answers. Now, what is the difference between that and this? What if I did 12 divided by 3 times 2, but now I did this? Well, now I'm forcing you to do the 3 times 2 first, right? Now you're gonna have to do this first. So this is gonna be 12 divided by 6. And yes, that would give you the 2. right? Or I could have done like 12 divided by 3 times 2 and done the parentheses here. And in that case, you're going to get the same answer as the first one because you're going to do these first, which is order of operations would have told you that anyway. So this will be your 8. Okay, so parentheses matter as well, don't they? Where they're positioned. All right, a couple of other things before we get into more of these problems. This was just to establish the fact that even though you may think you know all this, there are some little subtleties, so please pay attention. What does this mean? What if I take a number like -4 and I put these 2 bars next to them? What does that represent? Go ahead. It's called the absolute value. And what does it spit out? What is the absolute value of anything spit out? The positive, right? The positive. So this is 4. If I did, what's the absolute value of 4? What would that be? 4, right? Anytime it's a negative number, it spits out the positive. If it's a positive number, it spits out the positive. It really is like the distance that number is from 0. It's like measuring how far away from 0 it is. What, by the way, what is the absolute value of 0? 0. Absolute value of 0, 0. Okay, so you all seen that notation before, right? Okay, and then how about exponents? Just to make sure you understand exponents. What would that be? 9. So what are you doing here? What does that really mean you're doing? 3 times 3, right? So that gives you 9. What is this? 9? Sure. Negative times negative is? Anyone object? Is this 9 or is this -9? The correct answer to this is -9. Okay, so this is, again, this is why I'm showing this to you. Everyone knows, well, I think everyone knows, a negative times a negative is positive, right? Okay, so we're comfortable with that. But the problem with this is that that exponent is actually only attached to that 3. You really need to look at that as being -1 times 3 squared. That's technically what that is. The -1, the negative out front is like a -1. And so you're only squaring the 3. So you square the 3 and get 9, but then you multiply it times -1 and you get -9. That is different than this. Now, if I write that down, right? Now that's 9. Because what I've done is I've forced the -3 into the parentheses, meaning that the squared is going to act on the whole thing. That's -3 times -3. This is equal to 9. There, I agree. Right? These are little subtle things in our notation that we have to be comfortable with, or else, you know, math just becomes so hard because we don't understand these little things, right? Questions? I'm trying to work out all these little things before I start giving you some problems to do. How about this? This one's tricky. What's 12 over 6 over 3? You could say that this is like a fraction over a fraction, right? It's like a fraction within a fraction. Kind of weird. So there's kind of like 2 different ways I can look at this. One way I could look at it is that this is 12 divided by 6, and then divide that by 3, right? You see, that's one way I could kind of look at it. But another way I could look at it would be the 12 over, and then I do the 6 divided by 3. Would these give us different answers? Let's see, if I looked at these 2 different ways, would it give us different answers? What's 12 divided by 6? 2. And then 2 divided by 3 is just whatever 2 divided by 3 is, right? Here, if I did this, what's 6 divided by 3? 2, right? So this would be 12 divided by 2. What's 12 divided by 2? 6. You'll see the difference between these two. And it all just mattered like which way I looked at it, right? So which way do you look at it? This is not in your Pemdas, right? This is not in Pemdas. Well, I'm doing this on purpose. I tricked you. Not tricked you, but I wrote the problem wrong. If I wrote something like this, that's on me. I did it wrong. I need to somehow tell you which of these two cases it is. So the way I do that is this. When I write this problem, so this is incorrect notation on my part. If I write 12 and then I put a long bar and then 6 divided by 3, that would be this case. All right. Notice the long bar here. That forces this to be done first, then that comes in. If I wanted to do this one, I would write it like this. 12 over 6, short bar here, long bar here, 3. That would give you this. You'll see the difference between the two notations. Long division bar, small division bar. That tells you how to separate things. All right, I think I'm ready. You ready? I'm going to give you an expression and I want you to simplify it. I'll do one, then I'll give you one. Then I'll do one, then you do one. First one, simplify. Remember what I said last class. Don't let the idea that you're never going to be doing this math get in the way of you, like, participating and not turning everything off in here. This is about trying to use a certain part of your brain, right? This is what this is about. So I know it can be discouraging because we're sitting here doing arithmetic, but hang in there. We'll do harder stuff and more complicated things later. All right, here we go. How about this? I want you to simplify this expression. -3 parenthesis 2 minus the absolute value of -4, all of that squared, over -3 squared plus 2. All right, so I'm throwing you right into the fire here, right? There's a lot to figure out, lots to pay attention to. So when I'm looking at this, I have this big division bar right here, right? This division bar acts like a set of parentheses. It separates the top, the numerator, from the denominator. So you're gonna have to figure out everything up here first, then everything here, then you can put them together. So let me start on top. Do you see parentheses? We're doing Pemdas. So parentheses, I need to work in here first. I'm going to ignore everything else. This right here, absolute value of -4, really turns into a what? 4. So I'm going to actually write this. I'm going to do a lot of writing right now. I'm going to rewrite this as 2 minus 4, then that square, all over -3 squared plus 2. So the only thing I did there is turn that absolute value into this. That's all I did, right? Here to here. Now what? Do the 2 minus 4, right? In that parenthesis. What's 2 take away 4? -2. What's next? Exponents. So this is multiplication here, isn't it? Multiplication comes after exponents, right? So we need to do this exponent first. We need to do this thing. What is -2 squared? Positive or negative form? Positive, right? It's -2 times -2. So we're going to have -3 times 4 over. Let's go ahead and square this. Let's do this exponent now as well. What is that? What's -3 squared? 9? -9 or +9? Negative. Why? No parentheses around the -3, right? So this is -9 plus 2. We're almost there. On the top, -3 times 4, -12. On the bottom, -9 plus 2, -7. A negative divided by a negative is positive, so this is positive 12/7. And can I reduce that fraction? No. What type of fraction is that? Improper, right? Improper, I can leave it or I can convert it to a mixed number. I'm going to leave it as improper. You ready to do it on your own? See if you can do it? Here we go. I'll leave that up on the board. Mine's, I'm going to give you a different problem. It's not going to be exactly the same thing, but let's see if you can handle it. How about this? 2 times 3 squared plus 2 cubed minus 4, and then another set of parentheses, absolute value of -5 minus the absolute value of -5 to the third power. I know it looks bad, but just take your time with it, all right? It looks worse than it actually is. Just go methodically through it. You getting anywhere? It's so quiet in here. Does anyone have an answer yet? Show of hands. Okay, quite a few of you. While I'm letting others finish up here, I put the homework assignment on the board here, and actually it's out of order. This is what you should do first, and then this is the second part. So that first part has to do with adding and subtracting fractions, multiplying and dividing fractions, and then the second part here, page 222. Has word problems where you're adding and subtracting, multiplying and dividing fractions. So on page 221, 1 through 16, I put as needed. Like if you feel comfortable with that, you don't need to do all 16 problems. But if you feel like you need practice, do as many as you need. So these are word problems. These are just regular problems. And then 225 are going to be nothing but these types of problems. Page 225. A bunch of things like this to do. I'm gonna do some more. I'm putting the homework up there now. All right, can we talk about this yet? You all ready? Let's look at the first parenthesis. What have we not heard from today? Giselle? Where's Giselle? Am I saying that right? Giselle? Zachary? Right there. How's it going, Zachary?
Yes.
Good? It's all okay with you or you know? Yes? Okay, help me out with this. What did this turn into here? 9 plus 8, good. So everyone, Zachary's doing 2 to the third power. That's 2 times 2 times 2, right? Not 2 times 3. Right? It's not 6. It's 2 times 2 times 2. All right, good. You want to keep going over here? Or you want to go back? Okay, so what do you got? -4. You got 0 here. All right, did y'all get 0? You should have got 0. Absolute value of 5 is 5. And then you take away 5, right? Because that's another absolute value of 5. 5 minus 5 is 0. And isn't that going to kill everything over here, right? This is 0, 0 cubed is 0, 4 times 0. This is all gone. See, it wasn't as bad as it looked. And then over here, we just add these, right? 2 times, do the addition first, you go with 17 in there. And then that adds up to be, or multiplies out to be what? 4. All right. Yeah. All right, I got another one for you. This, yeah, go ahead. What?
5 minus 5 is 0.
0. So you have -4 times, right? Times 0 cubed. 0 cubed is 0 times 0 times 0. That's still 0. And then -4 times 0 is 0. So that kills all that off. And so that all that's left is that this up here. Did you see? Yeah. Okay. It takes a long time to get so comfortable with math and the notation that you don't make little mistakes. I mean, just I understand how challenging it is. It's like learning almost a language where there's all these little nuances that you have to be comfortable with. You mess one little thing up, throws everything off. Okay, so here, let me give you another one to do. All right, this one's just right out of the packet. It's not a homework problem, but it's a problem that I can demonstrate to you. So I want to see if you can do this one. Problem is I can't read from there. Let's see. So it's 2 plus 2 times parenthesis 3 minus 6 minus parenthesis 1 plus parenthesis 1 minus 4 squared. Oops. 1 minus 4 that squared. Close the parentheses. Square. Take your time. I'll have students that come and they take the test and they try and do it all in their head and they get it wrong. And I take off a lot of points if that happens. If I see your work and I see where you make the mistake, I'm not going to take off as many points as if you just have an incorrect answer. So I want to see steps. Also, this is not about just sitting here trying to punch this all into a calculator as well. Okay. You don't have anything to write with, or?
Yeah, I don't know.
Would you like a piece of paper? I'd like for you to have a piece of paper. Yeah. Does anyone have a sacrificial piece of paper that you'll never see again? I just want to see people do math. I mean, that's why you're here. Also have whiteboards in the corner. With their password. Okay. Anybody having trouble? Raise your hand. I can come by and kind of make sure you're getting off on the right foot there. Well, help each other out. Check with each other. How about over here? Well, there's nothing else you can do with that, right? So like, once you do this, and you get -3 squared, you get +9, there's nothing else you can do with +9. And then move on to the next thing. We're gonna do that. But I'm more concerned, did you have a 4 out there? Oh, okay, I see what you did. Okay, so you had already done all this?
Yeah.
Okay, so that -4, was there a minus after it? Yeah, that's minus after. Okay, good. I just want that right. Yeah, okay, you should be good. What else? You want me to look at what you've got and see if it's feel good? Let me start working this out, okay? I'm gonna start working this out. 2 plus 2, I'm gonna do what's in this parenthesis, that's -3. Minus, parenthesis, 1 plus. I'm gonna do what's in here now. -3, right? 1 take away 4, -3 squared, then all that squared. So the only thing I did on that first line is put those together and put those together, right? That was my first step. Now, the next line that I'm gonna do, I'm gonna work just in this parenthesis here. I could multiply those together, I'm not going to. Okay, I could do -3 and square it. +9. All that squared. So all I did on that step was this, right? Next line, what I'm gonna do is I'm gonna put those two together. 2 plus 2 times -3 minus 1 plus 9 is 10 squared. Next, I'm going to square the 10. Ten squared is 100. I'm down to multiplication. That's all I have left. So this is going to become 2. What is plus? Let's see. What is 2 times -3? -6. And then I still have minus 100. What's 2 add to it? -6. -4. If you add a negative number to a positive number, you're subtracting. So this is really just -4, take away 100. And what's that? -104. So from here to here, I did that. Next line, I did this, became that. And then on the next line, this whole thing became that. And on the next line is this together, and this, and then put it all together. So much room for error, right? There's so many little places you can make mistakes here. which is part again of what this is all about. This is about, can you do a procedure without making mistakes, right? I can't get a read off of you all. I can't tell if this is like so easy, if you're insulted, or if it's like, oh shit, this is why I don't like math. You know what I mean? I can't tell. So it's just a long time. Yeah. You gotta get all the rust off of it. Yeah. Okay. I want you to tell me, feel good about it. Tell me if you don't, then, can I erase? What do you say we do one more? One more? One more? Okay, one more. But then this is why homework is important. If you're sitting here struggling with this, if you're like, oh my God, if that's what you're doing in the back of your mind, then this is when you go and you sit down at the tutoring lab, you get help, right? You come to my office hour. This is where it's your job as a college student, right? To invest in your own learning. I said this a lot last time, I almost probably pissed people off. This is not high school, okay? You're not going to get a grade for showing up. You don't get a participation grade in here, all right? You do, but it's a small percentage of your grade, all right? You have to perform, you have to be able to do this. So when you leave, if you leave and you're unsure about things, there are plenty of resources here to help you. You just have to go and do that part of going and getting the help, all right? All right. 3 plus 2 parentheses 4 plus -6 in parentheses, close that parentheses, plus parentheses 1 plus -2. This is not necessarily like a harder problem. I'm just picking another one out of here. Where to start? So how do you feel about that? Like when you look at that, do you feel comfortable how to get that? Okay, you don't. No? Okay, so think about it like money, right? This 4 is like you have $4, right? Okay. And then you want to add to that, now you have -6, which means you owe somebody, right? So how much would you have total if you had 4 in your pocket, but you owed 6? Negative. Yeah, -2, right? Does it make sense that way? Okay, so then let's just rewrite the next line. And now just in this parentheses, replace all this with what? -2. Okay, good, good. See? All right, okay, now continue over here. I'll let you. Yeah. Yes. Yeah. If you go to the website Canvas for the class, there's a link to the what I call the packet, and you can open it up there electronically. And then you do your homework outside the packets. Like you read the packet, but your homework is just on paper and pencil on the side. Okay. Anybody have any questions here? Yeah. The answer should be 4. Quick show of hands, be honest. How many of you got 4? I just want to see where, oh, okay. What are we doing here? We should have left 10 minutes ago then. All right. This is your homework assignment, right? This is your homework assignment. I do plan, we're not going yet. Anyway, let's go. Please, especially if you're struggling with any of this, do it, do the work, right? Because that's the only way you're going to get comfortable with anything in math. You've got to practice. You can never sit here and watch me do problems and be like, yes, I understand that, I'm good to go. It's a matter of you sitting down and starting the problem and ending the problem yourself. Watching me, I know where to go, right? Like I know the path, I know. So you need to get that yourself, all right? You have to work on that. All right, so the last thing I want to do here, very last thing, is I like to sometimes in our classes give you something that is totally disconnected from the class in the sense it's kind of like random, useless information, but at the same time, it's somewhat interesting. And this is what maybe I would make a bonus problem out of on a test, right? I won't do this every class, but I will do it sometimes. So I'd like to share a quick story with you. And I should probably tell you that not everyone here is going to follow this. All right. I mean, not everyone will. And it's okay if you don't follow this, it's okay. Because this is going to be bonus material if it appears on the test. So there's a story that goes back to the late 1800s about this kid. His last name was Gauss. Okay. Last name was Gauss. And when he was in kindergarten, he went to class one day, and the teacher, this is late 1800s, the teacher went up in front of the class and said, okay, class, this is kindergarten. He said, what's 1 plus 2? And the kids, raised their hand. And said, oh, this is 3, right? Okay, he said, very good, very good. He said, what's 1 plus 2 plus 3? So what's 1 plus 2 plus 3? I mean, this is not a trick question. Okay. 6, right? Okay, what's 1 plus 2 plus 3 plus 4? 10, right? Okay. So the teacher said, all right, now class, what I'd like for you to do is figure out what's 1 plus 2 plus 3 all the way until you get to 100. And then he let the students work on that problem. And the story goes that the teacher just didn't want to deal with them that day. Right. So he was just kind of like, I'm going to give them some busy work and I'm going to go do something else, update his Twitter. No, there was no Twitter. He would just, I don't know what he's going to do. Right. He's going to sit there. And the story goes that within a few minutes, Gauss takes his little chalkboard, because they used to write on chalkboards, little miniature slate tablets, and they would write with chalk. And then when they were done in class with the problem, they would turn their chalkboards over and they would sit with their arms crossed, because back then they had like discipline and all that other stuff, right? So they just sat there. So he sees Gauss turn over his slate and just sit there. And he gets up and is kind of pissed off and walks over to Gauss and turns the slate over. And when he turns the slate over, Gauss has written n times n plus 1 divided by 2, right? And so the teacher looks at Gauss and is like, what the hell is that? Now, he may not have passed, but he said, what the hell is that? And Gauss explains to him, look, you wanted me to add up 1 plus 2, 1 plus 2 plus 3, 1 plus, and you wanted me to go all the way to 100. He said, this is a formula where whatever the last number is, that's the n, and you just plug it into this formula, it'll give you the answer. So like, for example, on this example here, the first one, the last number is 2, right? So let's plug 2 into this, see what you get. What's 2 times 2 plus 1 divided by 2? So that's 2, what's 2 plus 1? 2 times 3 over 2, isn't that just, the 2's canceled, you just get 3, right? That's the answer. We can check it for the others, let's check it for 4. If we do 4 here, then we're gonna go 4 times 4 plus 1 all over 2. That's 4 times 4 plus 1 is 5, divide that by 2. That's 20 on top divided by 2, that's 10, isn't it? Seems like it works. Right? Seems like that works. So the answer here would be, if I want to go out to 100, I just put 100 right here and 100 right here. Make sense? That's how the formula works. So the teacher turns it over, sees the formula, and the teacher gets pretty pissed off because the formula was known at the time. Like math people know that this formula existed. It wasn't like Gauss was the first person to ever discover this formula, but he's in kindergarten, right? So the teacher's like, where did you get that formula? Who showed that formula to you? And Gauss said, nobody showed the formula to me. He's like, I just figured out that that's what it would be. The teacher takes him out of the room, takes him to the principal, whatever, and tries to get him in trouble. So Gauss winds up having to explain how he got the formula. All right, so I'm going to show you his explanation. You ready? It's going to be a few minutes. So I'm Gauss, I'm kindergarten. I'm trying to explain to an adult how he came to this formula. See if you can follow this. So Gauss says, all right, you want me to add up 1 plus 2 plus 3 all the way out to 100, right? So the last number will be 100. The number before would be 99, the number before that would be 98, and so on and so on, right? Gauss says, that's what I'm trying to do. So let's call this, Gauss called it something. I don't know what he calls it, okay? The story, no one ever says what he calls it, but just out of respect for Gauss, I'm going to call it G for Gauss, okay? So let's call that some G. Now, there's a thing about addition. When you add numbers, it doesn't matter what order you add them. 1 plus 2 is 2 plus 1, right? Switch the order, it doesn't matter. Subtraction is different, but addition doesn't matter. So Gauss says, all right, I'm going to rewrite G, but I'm going to write it backwards. 100 plus 99 plus 98 plus dot, 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 dot. And then the last number is 1, the one before that's 2, the one before that's 3, right? So far, okay? You agree? G can be written either way? Okay, now the brilliant step. Gauss says, what if I added these two together? What if I add these? So I want you to think about this. If I add down, what would G plus G be? 2 G's, right? Like X plus X would be 2X. So he says 2G will be equal to, now start adding all of these down, one at a time. What's 1 plus 100? 101. Plus, what's 2 plus 99? 101 again. What's 3 plus 98? 101 again. You see what's happening here? 4 plus 90, right? This would keep going all the way down. We would have 101s. When you get to the last one, you would have 101, right? The one before that, 101. One before that, 101. With it? How many 101s are there? 100 of them. There's 100 of them, right? There's 1 of them, 2, 3, 4. The number of them here is actually this number, isn't it? So if I add 101 100 times, isn't that the same as doing 100 times 101? Right? So Gauss says 2G is equal to 100 101s. But we don't want 2G, we want G. So just divide both sides by 2. You all follow that? Yes? Okay. So I've lied to you. That's not the way Gauss explained it, but I always have to show that first. Okay, so I'm going to make a slight adjustment. Because do you remember what I put up here? What did the teacher turn over the thing? And it was n times n plus 1 over 2, right? That's what it was. That's the answer if you plug in 100 here, right? You put 100 here, 100 plus 1 is 101, then over 2. So that would be the answer if you had 100. So let me tweak it because Gauss did this. He said, you want me to add up the first 100 numbers, right? Gauss said, instead of adding up the first 100 numbers, I'm going to add up the first n numbers. Okay? The number right before n would be 1 less than n, wouldn't it? So I'm going to call it n minus 1. And the number right before that would be 1 less than that one, which would be n minus 2. Do y'all understand how that works or see that pattern? What would happen if you reversed it? write it backwards. This one would be n, right? The one right before it would be n minus 1. The one after that, n minus 2. Do you see it? Now add down. What's this together? N plus 1, right? That's what would happen if you add the first two together. What about the next ones added? What's n minus 1 plus 2? N plus 1. What's the next two added? N minus 2 plus 3. N plus 1. All the way down to the end. The very last one, N plus 1. How many of them are there? Not 100. N of them. There's N of them. So there are N of these. So twice what we want is N plus 1s. And then divide those sides by 2. You got the formula. Kindergarten. So as you might expect, Gauss went on to do brilliant things in mathematics. We will do something later this semester called solving systems of linear equations. And the method we use to do that is actually called Gaussian elimination. Named after him. So pretty brilliant, huh? I mean, do y'all kind of follow this? When you see it, it's not terrible, right? Well, wait, some of you don't want to see this, but it's okay. But I mean, most people can follow it. That's what separates genius from just us regular people. Is like someone came up with this without someone showing them, you know, and then they show it to someone like, wow, that's incredible. I see what you're doing. And I would have never thought of that, right? So anyway, okay, so you know what your homework is, right? And have a good weekend. Bring your homework to class. Be prepared for a quiz. Next time. Be over your homework. So practice, practice. The homework is in the packet. Open up the electronic version of the packet and you'll see these pages. Yep. Or if you have the hard copy. Great weekend, everyone. Right? It's Wednesday. I did not, for last time, I did not collect that. But bring it next time. Oh, okay. Thank you.
I had a-
Let me turn the recording off.